Hi, welcome to Algebra 2 Common Core. Today we're going to tackle a rather challenging topic, combining rational expressions using addition and subtraction. So if you have a highlighter, I would highlight some of the important things in this first box. The guidelines for addition and subtraction, the very first thing is that when I am adding and subtracting, it's going to be different than multiplication and division. In multiplication and division, I did not need a common denominator. But with addition and subtraction, of course, we are going to need a common denominator. So we're going to focus today on making common denominators. Now, the only way that I can change a denominator is by multiplying the fraction by something that has a value of 1. So we're going to see that right off the bat with our first example here. In example number 1, we're going to work with monomial denominators. So notice that our denominators do not have any addition or subtraction. We want to combine the fractions by first finding a common denominator. So looking at my first two fractions, I have denominators of 4x and 6x. I'm going to look at this and say, well, the least common denominator for those two denominators is going to be a 12x. So I need to multiply the numerator and denominator by each fraction by something that will make my denominator be 12x. So for example, in the first fraction, I've got a 4x. I want my denominator to be a 12x, so I'm going to multiply by the fraction 3 over 3. Notice that when I multiply the denominator by 3, I'll have a 12x. I can only multiply the numerator and denominator by a fraction that has a value of 1. So 3 over 3 is equal to 1. In that way, I'm not going to be changing the value of my original fraction. Likewise, with the second fraction, I want my denominator to be a 12x, so I'm going to multiply the numerator and denominator both by 2. Again, notice that I'm multiplying by something that has a value of 1. So I'm not changing the value of my original fraction. I'm just changing the way that it looks so that I will have common denominators. Now go ahead and multiply the numerator in the first fraction by 3. So 3 times 2x is giving me a 6x. 3 times negative 5 is negative 15. My denominator will now be 12x. Add on the second fraction. So for the second fraction, I'm going to multiply the numerator by 2. So that's going to give me 8x plus 4. And likewise, I'm going to multiply the denominator by 2. So I have my common denominator of 12x. Because my denominators now match, I keep that common denominator and I add like terms in the numerator. So 6x plus 8x gives me 14x. Negative 15 plus 4 gives me negative 11. When I look at this result, this sum, I see that my numerator cannot be factored, so therefore there's no simplification that can happen here. So I'm going to say this is the sum of those two fractions. Let's try exercise B. 4x minus 1 over 5x plus x plus 5 over 10. I want to find my least common denominator for 5x and for 10. So I'm going to say that the least common denominator, 5 and 10, both go into 10, but I also have to have an x in my common denominator because the first denominator has an x. So what shall I multiply the first fraction by to get the denominator to be a 10x? I'm going to multiply the numerator and denominator by 2. What do I multiply the second fraction by? I'm going to multiply the numerator and denominator by x. So in the numerator of the first fraction, I'm getting 8x minus 2 over 10x plus, now be careful, let's distribute that x through the x plus 5, so that's going to be x squared plus 5x, also over 10x. I've achieved my goal of getting a common denominator, so I keep that denominator of 10x. I add together the numerator. So I'm going to put this in standard form, so start with the x squared term. 8x plus 5x gives me 13x, and then I'll have a negative 2. Again, this numerator is not factorable, so there's no simplification I can do. I can never cancel off just an x because the numerator is a polynomial. Now let's go ahead and try C. For C, I've got denominators of 4x and 2x squared. So my least common denominator, 2 and 4, both go into 4. That's the smallest number that is the least common multiple of 2 and 4. Now I also need to have enough x's so that both of my denominators go into my factor of x. So that's going to be an x squared. To change my first fraction, I'm going to have to multiply the numerator and denominator both by x. To change my second fraction, I just need to multiply the numerator and denominator by 2. So for the first fraction, I get 3x over 4x squared. For the second fraction, I'm getting 2 over 4x squared. I have my common denominator of 4x squared, so I keep that. Add together my numerator. Well, these are not like terms, so I'm just going to have to write it as 3x plus 2. And again, don't be tempted to try to cancel off any x's because the numerator has a polynomial, so I can't just take off part of that polynomial. So far we've looked at just monomial denominators. In the next group of examples, we're going to be looking at what happens when we have polynomial denominators. We're going to have to combine the fractions by factoring the denominators first. When we factor those denominators, then that will help us to find a common denominator. Once our fractions have a common denominator, then we'll be able to add or subtract. So let's look at exercise A first. So in exercise A, I have 4 over 5y minus 15 plus 5 over y squared minus 9. Let's factor both of these denominators. So that's going to give me 4 over 5 times y minus 3. For the second fraction, 5 over y plus 3 times y minus 3. Now when I look at my denominators, all of the factors of each denominator have to be in my least common denominator. So I'm going to come over here and list down all the factors that I need. I need a 5 because the first fraction has a 5 in its denominator. I need a y minus 3 because the first fraction and the second fraction both have a y minus 3. Notice that I don't have to use it twice because each one only has one factor of y minus 3. And then I need one factor of y plus 3. So just like in the first example, I am going to multiply my numerator and denominator by whatever the denominator, the least common denominator, needs that the fraction is missing. So for example, the first fraction, 4 over 5 times y minus 3, that's missing a y plus 3. So I'm going to multiply the numerator and denominator both by y plus 3. And it's going to look something like this. Multiply the whole fraction. The second fraction already has a y plus 3, already has a y minus 3. The only thing it's missing is that factor of 5, so I'm going to multiply the numerator and denominator by 5. Now look at our simplification here. In the first fraction, 4 gets multiplied by y plus 3, so that's 4y plus 12, over my common denominator, 5 times y plus 3 times y minus 3. Second fraction, multiply 5 times 5, that's 25. That's going to be over the common denominator, 5 times y plus 3 times y minus 3. Now that I have my common denominator, I keep that denominator, 5 times y plus 3 times y minus 3. And I add together my like terms in the numerator, 4y plus 37. Now that numerator is not factorable, so this would be my final answer. Sometimes if we get a multiple choice answer, we may have to multiply the denominator back out again. So I might get a final answer of 4y plus 37 over, let's see, I get y plus 3 times y minus 3, that's y squared minus 9. But then when I multiply that by 5, that would be 5y squared minus 45. So this would be an equivalent answer. If you're just showing your work, you only need to go this far. As long as it's not multiple choice, you can leave your answer just like that. Let's try example B together as well. So again, I see that I have polynomials in my denominator. So let's go ahead and factor. So my first fraction, ooh, that's a little messy. Let's try that again. X minus 3 over, let's factor, and I get x minus 5 times x minus 4. Second fraction, factor that denominator, x minus 4 times x minus 2. So I'm going to come off to the side and say the least common denominator has to have an x minus 5 from the first fraction, an x minus 4 because each fraction has that factor, and an x minus 2 because the second fraction has that factor. What's my first fraction missing? It's missing the x minus 2, so I'm going to multiply the top and the bottom by x minus 2. Second fraction, that one's missing the x minus 5 factor, so I'm going to multiply the numerator and denominator by x minus 5. Now, if you have to slow down the video to think about why each of those fractions get multiplied, go ahead and do that. This is a really important topic here. Now, in my first fraction, I'm going to have to go ahead and multiply, but I see that I've got a binomial times a binomial, so make sure you do your double distribution there. So multiplying those through, I'm getting x squared minus 3x minus 2x gives me minus 5x, negative 3 times negative 2 plus 6. I'm going to keep my denominator in factored form, so x minus 2 times x minus 5 times x minus 4. Plus, second fraction, distribute the 2 times the numerator, so 2x minus 10 over common denominator. Now it doesn't matter what order I write my factors in my common denominator, they're just all being multiplied together. Now let's add together the like terms in the numerator, so I'm going to say x squared, negative 5x plus 2x is negative 3x, positive 6 plus negative 10, negative 4. Still over that common denominator of x minus 2 times x minus 5 times x minus 4. Now here's an example of an answer that can be simplified further. In my numerator, that's factorable. So let's factor x squared minus 3x minus 4 into x minus 4 times x plus 1. Denominator still x minus 2 times x minus 5 times x minus 4. Now remember back to all of the work that we've done with rational expressions. When we have like factors in the numerator and denominator, we can cancel them because we can divide both the numerator and the denominator by x minus 4. And my final answer is going to be x plus 1 over x minus 2 times x minus 5. And likewise, you can leave your answer just like that, or you can multiply that denominator back out again using double distribution. Now we're going to head to some subtraction problems and see how that's going to be slightly different. In example A, we can see that we already have a common denominator, so it's not even necessary to go ahead and factor. We might have to factor in the end when we're trying to simplify. The first step for subtraction is to change to add the opposite. So remember that my first fraction is just going to stay at 3x plus 7 over x squared minus 4. But then I'm going to change this to add, and then take the opposite of both of the terms in the second numerator only. So negative x minus 3 over x squared minus 4. Now go ahead and add like terms. So 3x plus negative x gives me a 2x. Positive 7 plus negative 3, that gives me a positive 4 over x squared minus 4. Now again, be careful. Don't just think that we can cancel off those 4's because both are being added or subtracted within a binomial. Instead, what we're going to have to do is factor. So in the numerator, 2 times x plus 2. In the denominator, that's the difference of 2 squares, so that's x plus 2 times x minus 2. So go ahead and cancel off your x plus 2's. So your final answer should be 2 over x minus 2 for that subtraction. That was nice and easy because the denominators already matched. Let's look at B where the denominators do not match. So the first thing I'm going to have to do is change to my add the opposite, and then go ahead and factor the denominators. So I've got x minus 3 over 2x plus 1 times 2x minus 1. Second fraction, negative 2 over 5 times 2x plus 1. So, looking at my denominators, I need to figure out my least common denominator. I need to have a 2x plus 1. I need a 2x minus 1. And I need a 5. So the first fraction is missing 5. The second fraction is missing 2x minus 1. So take a minute, distribute those numerators, add together the numerators, and come back and see if your work matches mine. So simplifying, I got 5x minus 15 over my common denominator, plus negative 4x plus 2 over my common denominator. Adding together the like terms, that's going to be x minus 13 over 5 times 2x plus 1 times 2x minus 1. And this answer cannot be simplified. Let's go on to example C. Again, I have a subtraction example, so I'm going to change this to add the opposite. Let's factor our denominators. So we've got x over x plus 2 times x minus 2. And negative 6 over x plus 10 times x minus 2. So our least common denominator has to have an x plus 2, an x minus 2, and an x plus 10. So let's multiply our first fraction by what it's missing, which is x plus 10 over x plus 10. Let's multiply the second fraction by what it's missing. That would be x plus 2 over x plus 2. So this time we've got to distribute. So x times x plus 10, that gives me x squared plus 10x over the common denominator x plus 10 times x plus 2 times x minus 2. For the second fraction, we're going to say negative 6x minus 12 over x plus 10 times x plus 2 times x minus 2. Go ahead and add together your like terms, so that's going to be x squared plus 4x minus 12 over x plus 10 times x plus 2 times x minus 2. Factor your numerator. So this factoring is going to give us x plus 6 times x minus 2. We're hoping to be able to cancel like factors so that our answer will be more simplified. So I see that yes, I'm going to have a common factor of x minus 2. So when I cancel those off, my final answer is x plus 6 over x plus 10 times x plus 2. Now we're going to save example D to do together in class. I want you to focus on example number 4 next. And if you would take a few minutes to try example 4, which is a multiple choice question, and go ahead and do the problem and then come back and check with my work and see if you match. For example number 4, the least common denominator should be x times x minus 1. So the first fraction has to be multiplied by x on the top and the bottom. The second fraction I changed to add the opposite, so now I have a negative 1 in the numerator, and it's missing the factor x minus 1. So I'm going to multiply the numerator and denominator by x minus 1. Once I do that, I put together my like terms. So in this case, the positive x and the negative x canceled, leaving me just with a 1. Now this is one possible answer, but I saw that none of my multiple choice answers match that, so I went ahead and distributed the x times the x minus 1 to get choice 3 as my final answer. At the bottom of your note page, I'd like you to add one more you try it example. So copy this example down on your note page underneath the multiple choice question and do this problem. I'm going to do it as well, and then you can come back and check your work with mine. I factored the denominators, so I got 5 times x plus 2 in the first fraction, and x plus 2 times x minus 2 in the second fraction. So the least common denominator for these two fractions should be 5 times x plus 2 times x minus 2. Multiplying the first fraction by x minus 2 and the second fraction by 5. Look at our simplified rewritten fractions. Then I added together my like terms in the numerator. This time when I factored that numerator, it gave me 3 times x plus 8, but that wasn't helpful because it didn't cancel with anything in my common denominator. So I actually can leave my answer either in this form or in the form that I wrote over here. So we've practiced quite a bit with adding and subtracting fractions and finding common denominators today. If you've got any questions, please come and see me in the morning. And in class, we're going to be doing quite a bit more work with addition and subtraction. Thanks. Have a great night. See you next time.